Good morning, guys. Today we're going to be looking at notes 1.08, solving absolute value equations. So we're still talking about absolute value, but now we're going to be focusing on solving equations of absolute value, and we're going to be doing that throughout, but more focused at the end of the video. And we're also going to look at the relationship between the solutions of an equation and compare that to the x-intercepts of a function, of that function. So there's a relationship that we're looking at between these two. We're going to be comparing the graph to the solutions to the equation. So to start off, we're going to look at the absolute value. The absolute value as an equation, or just the operations that you can do on an absolute value. Move it a little bit up. There we go, that looks good. Okay, it says, remember that the absolute value of a number is its distance from zero. Okay, so a couple of examples here. Whether we're looking at positive or negative numbers, the absolute value is just considering, how many steps did it take to get there, not so much the direction that it took you to get there. So for example, if I'm interested at -4, I'm only interested in how far is -4 from the 0. How many units away is it? So it's 1, 2, 3, 4, 4 steps away. So 4 steps away. If I'm looking at 0, how far is 0 from itself? Well, it's 0 steps away. And then if I'm looking at +2, how many steps does it take to get to +2? 1, 2. 2 steps. So again, the absolute value of numbers, absolute value of -4, is looking at the distance from the 0. How far is -4 to the 0? How far is +2 to 0? How far is 0 to itself? Okay, so we have absolute value equations are equations where the variable is within an absolute value operator, like the following. So you have an equation, but when you add these vertical bars, this is called an absolute value operator. So the absolute value operator are these vertical bars. So I'm highlighting them in purple. So the absolute value operator are these purple bars, and when you have an equation with this operator in it, it's called an absolute value equation. Okay, a couple of things that we saw when we were graphing the transformations of the absolute value. Sometimes we would see graphs where it would have one x-intercept. So that's one solution. So let me pick a different color. I'm just going to color it in red. So I have one x-intercept. So we say that that's one solution, right? In this second graph, we have two x-intercepts, right? One on the left, one on the right. So we have two solutions. And then we have no solution when the third graph, there is no x-intercept. Okay, so these are the three situations that we saw throughout when we were graphing the different transformations of the absolute value. So we're going to keep that in mind as we look at some examples on the next page. So keep that in mind, right? If we have one x-intercept, that means we should expect one solution in the equation. If we have two x-intercepts, then we expect two solutions. And if the graph doesn't cross the x-axis, we have no solution. Okay, so let's jump over to the second page. Okay, so we have here a couple of steps that we want to follow when we're solving absolute value equations. Isolate the absolute value operator on one side of the equation. So we want to get the operator, the portion that has the two bars. This is the absolute value operator. Is this following operator. So we want to get the absolute value operator by itself. And then we have two situations here. I'm going to color code them. So if I get a positive number, positive number. If the equation is equal to a positive number, then we're going to write two equations separated by an or. And then we're going to solve. Okay. If I get a negative number, so if this equals to a positive number, we're going to follow the steps on the left. If this equation, whatever it is equal to a negative number, then we celebrate. In other words, we don't have to do much work. If it's equal to a negative number, there's no solution. If the equation is equal to 0, there's only one equation to solve. Okay, so if it's equal to a positive number, I have to solve for two equations, for both equations. And I'll explain that when we look at an example. But if this equation that we're trying to get by itself, if it's equal to a negative number, there's no solution. And then the last thing, if the equation is equal to 0, and there's only one equation. Okay, so we're going to look at these three scenarios throughout. So let's look at the next section here. This next section here is trying to make that connection I was talking about. So let me zoom out a little bit. Making sure I can fit everything. Okay, I'll just read it. So it's going to say, where it says, the solutions to an absolute value are the x-intercepts of its related function. Okay. The solutions of an absolute value equation, whatever we're going to get for this side, are the x-intercepts of its related function. Okay, so let's graph it first. We've been graphing in the previous topic, so we're going to graph, since that's what we're familiar with. So here we have plus 5. Okay, so plus 5 is happening inside the absolute value. So we have horizontal translation because it's happening inside, and we're going plus 5, so that means we're going to move to the left 5 units. Okay. So if I move to the left 5 units, I'm going to be there. Let me get something like this. Okay. And the question is, what is the x-intercept of this function that we just graphed? Well, it hits the x-axis at -5, 0. Okay. So now over here on the right, we're going to solve. We're going to solve. And here is where we follow the rules from the top of the page up there. It says that if we have to get the absolute value by itself, so we want to get this absolute value by itself on one side, which it is, and it's equal to 0. So it says up here again what I highlighted in pink. If the equation is equal to 0, there's only one equation to solve. So this equation down here is equal to 0, so I just have one thing to solve. So all I'm doing is I'm just going to take what's inside of the absolute value, the x plus 5, and set it equal to 0 and solve for x. So the opposite of adding 5, subtracting 5. This cancels. Bring down the x equals to -5. So the solution over here is x equals -5. But this also matches the -5 that I got when I graphed it. So the graph shows me that I get an x-intercept at -5. The solution when the equation equals 0 is -5, which is the same value as the x-intercept. So that's the relationship that we're looking at, is that if I have a function that I'm graphing and I find the x-intercept, I can look at the equation of that function. So the function was absolute value of x plus 5. If I set it equal to 0, the absolute value of x plus 5, if I put it equal to 0 and I solve for x, that gives me that solution there. Alright, let's go to the next example. And over here in this example, let me zoom out a little bit. Okay, so here we have kind of the same idea, but now we have a couple of transformations happening here. We have this this negative in front, which means that it's reflecting over the y-axis. Sorry, the x-axis. Then we also have this x minus 1, means that we have a horizontal translation to the right 1. And then we have this plus 3, which is a vertical translation up 3 units. So we're going to go to the right 1 and up 3. We're also going to reflect. Okay, so let's say I have the parent function. Right, so these 5 points in black are my parent function points. And so I'm going to reflect over the x-axis. So that's going to cause the points to appear downward, right? It's reflecting over the x-axis. So the x-axis is like my mirror, and so everything that's on top is going to be on the bottom. And then I'm going to move everything to the right one, or I'm just going to move the vertex to the right one and up 3. So 1, 2, 3. That's going to be my point. And then I'm going to draw the other points and draw my graph. Okay, I'm just going to erase everything else. There we go. And so the question is, what are the x-intercepts? Where does the graph hit the x-axis? So it looks like it hits at -2, 0. -2, 0. Or you can also say it hits at 4, 0. So it's at -2, 0 and 4, 0. Those are my two x-intercepts. And so now we're going to look at the right side and follow the steps to solve for the absolute value equation. We want to isolate the absolute value. So we want to get this section by itself. So I need to do the opposite operations. So I'm going to do -3, -3. The opposite of adding 3 is subtracting. Copy everything else. The plus and -3 will cancel. This equals to -3. Again, my goal is to get this absolute value by itself. So I need to get rid of this -1 here. So to get rid of this -1, it's being multiplied. So the opposite of multiplication is division. So I'm going to divide -1 on both sides. It's going to cancel the -1s. So I'm going to be left with absolute value of x minus 1 equals to negative divided by a negative is positive, and 3 divided by 1 is 3. Okay. All right, so now the absolute value is by itself. There's nothing around it. And so I got to my goal. And then the next question is the absolute value equation, is it equal to a negative number? Is it equal to a positive or a 0? And it's equal to a positive number, so then that says that we're going to have two equations. And so these are the two equations that we're going to set up. We're going to do x minus 1. So we're just copying the expression inside the absolute value. And we're going to put 1 equal to a -3. We're going to put or x minus 1 equals to positive 3. Okay, so it's like I have two equations in one. Actually, let me write it out a little bit different. Let me actually zoom in here so we can have more space. Or I can have more space to write. Okay, so what we're doing again is we're going to write x minus 1, which is the equation, is equal to, we're going to say a -3, or x minus 1 is equal to a positive 3. And so that's going to give us two equations to solve. So let's solve the one on the left first. So to solve for it, I have to add 1 on both sides. These are going to cancel. And I'm going to be left with x equals, what's negative 3 plus 1? That's negative 2. Okay, and then we're going to, now that we solved for x on the left, let's solve it on the right. So I want to get x by itself. What's the opposite of subtracting 1? Adding 1. So we're going to add 1 on both sides. And we get x equals 4. All right, so I've solved for those two equations. Why is that interesting, or what do you notice that is important here? Well, if we look at it, our answers were negative 2 and x equals 4. So I'm going to write that at the bottom here. The solutions of the equation are x equals negative 2 or x equals 4. And that's interesting because when I graphed this equation, my x-intercepts were negative 2 and 4. And my solutions over here are negative 2 and 4. So again, we're trying to make that connection that if I graph the function of the absolute value and that function has two x-intercepts in the graph, then I can also take this function on the left, set it equal to 0, put it equal to 0, work out the algebra, the math, and I can get two values that give me the same x-intercept. Okay. Now let's look at solving. Let's practice the steps that we've been doing over here in these next 5 examples. Okay. So here I can zoom in a little bit more because I have more space. That's a good amount of space. Okay. Okay, so solve each absolute value equation. Show all your work. Okay, so the first step is get the absolute value by itself. So I want to move the 4, the plus 4. So I want to subtract 4 on both sides. These 4 and negative 4 are going to cancel. Then I'm going to be left with x minus 3. Absolute value of x minus 3 equals, what's 2 minus 4? It's negative 2. All right, now I got the absolute value by itself. So the question is, what's happening here? What is this equal to? It's equal to a negative number. And so it says that if it's equal to a negative number in the rules, then there is no solution. So remember this, right? If I'm working on an absolute value equation and I get the equation by itself, but it's equal to a negative number, then I can stop right there and there's no solution. Okay. Now let's look at the next example, example 2. Okay, so I want to get the absolute value by itself. So I want to move the 1. The opposite of subtracting 1 is adding 1. So I'm going to bring the absolute value of negative 2x down. Negative 1 and positive 1 cancel. Bring down the equal sign. 5 plus 1 is 6. So this is equal to a positive number. So I'm going to have 2 equations. What are those 2 equations going to be? Well, I'm just going to copy. It's going to be negative 2x. I'm just getting what's inside the absolute value. So it's negative 2x. Actually, let me put this in purple. So I'm taking what's inside the absolute value, what's inside the purple, and setting it equal to a positive and negative version of what it's equal to. So I'm going to set it equal to negative 6, or we're either going to work with negative 2x equals to positive 6. So this is what happens if I solve for an absolute value and I get the absolute value by itself and it equals to a positive number. Then I'm going to get 2 equations. One that looks exactly like the original, right? Negative 2x equals 6. And another one that's negative 2x equals to a negative 6. So let's solve for both. How do I get x by itself? What's the opposite of multiplying by negative 2? Dividing by negative 2. So we're going to divide both sides by negative 2. The negative 2's on the left will cancel. So that'll leave me with x equals to positive 3. X equals to positive 3. And then on the right side, again, what's the opposite of multiplying by negative 2? Dividing by negative 2. On the left side of the equals, the negative 2's will cancel. That'll leave me with x equals negative 3. Alright, let's look at the next equation. Oh, this one is pretty nice. It's already equal to a positive number, or it's already equal to a number, and it's equal to a positive. So that means I'm going to end up with 2 equations. So they're going to be, one of them is going to be 2 minus x equals negative 5, or 2 minus x equals positive 5. So it's 2 minus x equals negative 5, using a negative version of the answer and a positive version of the answer. And so let's solve for x. You can get rid of the 2 by subtracting 2. It's going to cancel there. It's going to give me negative x equals negative 7. And then I want to get rid of the negative. It's kind of like I have a negative 1. So let me changing to the pen tool, but yeah, okay. So it's like I have a negative 1 there. So I want to divide both sides by negative 1. It's going to cancel these. X equals positive 7. Okay, then let's do kind of the same process on the right side, but instead of having a negative 5, we're going to work with a positive 5. So it's going to be minus 2, minus 2. Then we see that the 2 minus 2 will cancel. You're going to end up with negative x equals 3. So there's like a negative 1 there. So I'm going to divide both sides by -1. X equals -3. It's like 2 answers. And you can check them. You can plug them in over here. 2 minus 7. 2 minus 7 is -5. But the absolute value of -5 is +5. And then over here, if I plug this -3 over here, if I plug it in, what's 2 minus -3? A minus negative becomes positive, so 2 plus 3 is 5. Okay. Now let's look at the last 2 examples. Okay. Last 2 examples. So we want to get the absolute value by itself. So I can subtract 6 on both sides. That's going to give me -4 absolute value of x plus 3. Just copying. The positive and -6 will cancel. Then it's going to be equal to -14 minus 6. They're both negative, and there's subtraction going on, so it's going to equal to a -20. Then again, I want to get the absolute value by itself, so I need to get rid of the -4. It's multiplying by -4, so the opposite of multiplication is division. So the dividing is going to cancel that. I'm going to be left with the absolute value of x plus 3 equals to +5. Okay, so I got the absolute value is equal to +5. It's a positive number, so that means I'm going to end up with 2. Oh wow, my handwriting is getting sloppy. Okay, it's going to give me 2 equations. So the 2 equations are going to be the following. I'm going to have x plus 3 equals a -5, or x plus 3 equals to a +5. So on the left, I'm going to subtract 3, x is going to equal to -8. Then I'm going to subtract 3, subtract 3. It's going to give me x equals 5 minus 3, that's 2. These cancel. So I got -8 and 2. Alright, one more example over here. Again, I want to get the absolute value by itself. So I want to get rid of the -1. So I'm going to add 1 on both sides. Cancel. I'm going to be left with the absolute value of -x over 3 plus 7 equals to 10. 9 plus 1 is 10, right? So I got the absolute value by itself, and it's equal to a positive number, which means I'm going to end up with 2 equations. A negative, one that's equal to a negative number and one that's equal to a positive number. So it's going to be -x over 3 plus 7 equals to -10, or negative x divided by 3 plus 7 equals to positive 10. Okay, so I'm going to solve for x on the left here. It's going to cause me to subtract 7 over here, 7 over here. Bring down the negative x over 3. These 7s will cancel. And it's going to equal to negative 17. They're going to add, right? 10 plus 7 is 17, and they're both negative. Then the next question is, and actually let me move this fraction. Next question is, how do I get rid of that 3 in the negative? So the opposite of dividing by 3 is multiplying by 3. So I'm going to multiply actually both sides by negative 3. So again, this is multiplication, right? So that's going to cause the negative 3 and the negative 1/3 to cancel. So I'm going to end up with x equals to 17 times 3. That's 51. Okay, that's 51. Positive 51 because the negative times a negative. And for the sake of space, I'm going to copy this equation on the right. I'm going to copy it on the bottom over here. So I'm going to do negative x over 3 plus 7 equals 10. Okay, so again, I'm copying the equation that I wrote on the right because I don't think it's going to fit in this space. And so if I write it, we're going to solve for x. So subtract 7, subtract 7. It's going to cancel over here. Then be left with negative x over 3 equals positive 3. And then we're going to do the opposite of dividing by 3. We're going to multiply both sides by negative 3. This negative 3 and this negative 1/3 are going to cancel. And I'm going to be left with x equals negative 9. All right. So that brings us to the end of these examples. Again, I'll see you guys in class. And if you have any questions, feel free to bring them up there. And thank you for joining me today. Have a great day, guys.